So we already have an idea about how to find some important stuff for our polynomials, right? So we talked about graphing quadratics yesterday, and in order to graph quadratics, we came up with things like the vertex of the quadratic, right? That highest or lowest point, depending on its orientation. We found the zeros, right? And then we also, well, that was pretty much it, I guess, yeah. You can also find the line or stuff at the homework and stuff like that. But most importantly, right, we found the zeros, we found the vertex and stuff like that. And when it comes to graphing then a polynomial, there's one other kind of component that we need to include, but everything else is otherwise pretty much the same, and that would be the end behavior, okay, of a polynomial. A quadratic, we are more familiar, right? It has a very distinct shape. Either it's going to be that U shape or the bell shape, okay? Either both of the ends go up or both of the ends go down. But now, since we're talking about more of a generic kind of polynomial, we want to be able to describe, you know, the end behavior for those, and those can differ, right? They can be different. There's like 4 different combinations that you can have here. To talk about end behavior, though, we need to first recall what the degree of a polynomial is. Okay. And how do we find, or how do we calculate the degree of a polynomial? What is it? How do you find the degree of a polynomial? Yep, Ro? Mm-hmm. Yep, and in this case, it's the largest exponent, okay, in a polynomial. Okay, in standard form, I guess. Okay. So there are 2 things that affect the end behavior of a polynomial, or 2, you know, kind of like things that factor into it. Okay. So to determine end behavior, and I feel like this is something you guys have talked about before. So do you guys remember what's one important component in determining the end behavior? The what? The vertex? Well, I mean, potentially there. Well, we just talked about, I just introduced the idea of degree, okay? So we'll need to consider the degree. So the degree of the polynomial. Okay, the degree of the polynomial will determine that. And then also we want to consider the lead coefficient, specifically whether it's positive or negative. Okay, and those 2 things are going to affect the degree, or sorry, the end behavior. Okay, the end behavior. So let's look at, and so we'll just kind of break it down into 2 things here. For even degree polynomials, okay, for even degree polynomials, okay, if lead coefficient is greater than 0, like that. Well, if we're talking about even degree polynomials, this counts our quadratics, right? So quadratics count in even degree polynomials. Alrighty. And so what happens to our ends with a positive lead coefficient? How does our quadratic behave? If we have a positive lead coefficient, both go up. Exactly right. They both go up. Okay. So the way we're going to write that is not to say both goes up, of course, because that's, you know, not very officially mathematic and stuff. We're going to use essentially what are like limits, and we'll talk more about limits later. But we're going to say as x goes to infinity, which is really saying as we go really, really far, what direction? Right. To the right. Right. As you go really, really far to the right, all right, the function f of x goes to, and if it's going up, it should go to what? Positive infinity as well, right? So exactly right. So we're just going to use these things to describe it. Okay. So we covered x going really, really far to the right. We also want to cover x going really, really far to the left, which involves saying as x approaches what then? Negative infinity, right? And then f of x, in this case, would go to what? Still positive infinity, right? Because from the left, going farther to the right, going all the way to the right, going all the way to the left, both go up, right? Then if we flip that, and we say the lead coefficient is less than 0, okay, well, we're still going to have behavior as x approaches infinity and as x approaches negative infinity, right? We always have a behavior, for polynomials at least, as you go really, really far to the right, as you go really, really far to the left. Okay, so both of these will stay the same. But what changes is now as x approaches infinity, as we go far to the right, and we have a negative lead coefficient, what will f of x approach? What will the y values approach? Yeah, negative infinity, right? And then same thing, as you go really far to the left, the y values will also approach negative infinity. Okay, just like that. Okay. So that's a situation like this. There might be stuff that happens in between. Whoops, sorry, I'm off the screen. There we go. There might be stuff that happens in between, but then at the ends, you're going to have the up behavior, right? For number 2, there might be stuff that happens in between, but at the ends, you're going to have arrows both pointing downward. Okay, so whatever happens between, we'll worry about that in a second. But right now, we'll just stick with this. Okay, so that's your two, kind of situations with even degrees. If you have lead coefficient positive, it's this. Lead coefficient negative, it's that. Okay. This is not something that you necessarily have to memorize. You can kind of, figure it out if you, kind of get the idea down about what's happening here. Okay. Even degree polynomials, the end behavior is the same. Okay. Either both go up or both go down. All right. So about odd degrees here. Okay. So same situation. We'll do the same thing. So we'll say lead coefficient, okay, is greater than 0. All right. So again, we're going to talk about behavior as we go really far to the right, and we'll talk about behavior as we go really far to the left. X approaches infinity and negative infinity. Okay. So now think about like your cubics, right? That's something that's more familiar to us, a cubic. Okay. If we have a positive lead coefficient, so in other words, something like just x cubed, as we go really far to the right, what is the function doing? Does it go up or down? It goes up, right? So it's going to go to infinity. All right? And then as x approaches negative infinity, f of x will approach negative infinity. We're going back down there. Okay. And then finally here for our last little thing. So if the lead coefficient is negative, this will cover all of our bases now. Less than 0. Then as x approaches infinity, f of x will approach negative infinity. That's right. Okay. And as x approaches negative infinity, f of x will approach positive infinity. Yep. Okay. And again, this would be like okay, something like that. And something like that. Again, the dots are kind of like there's stuff happening between there. But we're just worried about that end behavior. Okay. All right, so let's do 2 here together. We'll practice to determine end behavior, and then I'll have you guys try 2. And then we'll graph 2 polynomials. We'll be done. Okay, so example. Okay, let's determine the end behavior of, and then number 1, we'll say g of x equal to 3x to the 4th minus 5x squared plus 4. And they'll also do this one here too together. H of x equal to x times x to the 4th minus 1. Okay, so there are 2 examples. I'll let you guys catch up here with the writing, and then we'll g of x is 3x to the 4th minus 5x squared plus 4, and h of x is x times the quantity x to the 4th minus 1. Okay, so number 1, okay, then we have to look at 2 things here. We have to look at the degree and the lead coefficient. All right, what is the degree in number 1? 4. Okay, highest power term is 4. And what is the lead coefficient? 3, which is positive. Yeah, either one's fine there. Yep, 3, which is positive. Exactly right, because that is the key kind of piece of information. Okay, every end behavior that you describe, you need to start out as x approaches infinity, as x approaches negative infinity. You need to describe both ends, right? There's two ends to a function. The right end, that's the x approaches infinity part. The left end, as x approaches negative infinity. Okay, we'll say here, in this case, it's g of x is the function, so I'm going to say g of x instead of f. Okay, so as x approaches infinity, g of x, all right, so now we have to think here. The degree is 4, so that means it's even. So it means either both go up or both go down, and the lead coefficient is positive. So what's g of x going to approach here? As x approaches infinity, we'll say g of x approaches what? Infinity, right? Yep, we have a positive lead coefficient, even degree. And as x approaches negative infinity, g of x will approach infinity as well. Okay. And again, we have to use this idea of approaching, right? You never really get to infinity. It keeps going, right? Okay, in math at least, it keeps going. So like you never say equals infinity, right? That's not really mathematically correct. You always are approaching it, okay? And you also always have to approach infinity from a side, right? You can't approach positive infinity from values greater than infinity. You can only approach positive infinity from the left-hand side, right? From values smaller than infinity, because you can't really get bigger than infinity. Okay, so anyway. Number 2, and that's again more of a calculus idea. We'll talk about like one-sided limits and stuff like that a little bit later in pre-calc too, I think. But anyway. Okay, number 2. Same thing, I'm going to go ahead. I know I'm talking about end behavior, so I know I'm going to have to describe what happens as x approaches infinity and as x approaches negative infinity. Okay, we're talking about h of x now. Okay. Okay, what is the degree here? 5, but I see a 4 as the biggest number. Where did you get 5 from? Yeah. Yeah, it's not really in standard form there, right? We want to distribute that, and so we really have x to the 5th minus x. And so, yes, this is an odd degreed polynomial here, okay? Positive lead coefficient. So think of like a x cubed, right? What the end behavior will be like. So as x approaches infinity, h of x will approach infinity, and as x approaches negative infinity, h of x will approach negative infinity. Okay? Now, this is kind of a lot to write. If you want to, I will allow you guys to be a little bit lazy here as something like this. So I think you should be able to combine these two statements together as something like this. As x approaches plus or minus infinity, h of x approaches plus or minus infinity. Okay, so if you want to combine these two statements together as one statement, I'll accept this, with the idea being that as x approaches positive infinity, h of x will approach positive infinity, right? And as x approaches negative infinity, h of x should approach negative infinity. So like they line up. You see what I'm saying? Whereas over here, if I wanted to combine this together, I would say something like as x approaches plus or minus infinity, g of x approaches, well, since they both approach infinity, I'll just say g of x approaches infinity. So if you want to combine them all together in one statement, you don't have to like rewrite stuff, you know, kind of thing, feel free to do that. Okay, you can combine them together, or just leave them separate. Your choice. Okay. Your choice now, try these two, okay? So I'm going to give you f of x equals negative x times x minus 2 times x plus 2. And 4, I'll give you negative 13x squared minus 2x minus 5. And that is also f of x. We'll say I put that backwards there, but oh well. Okay. So give those two a try. If you want to do it with the two statements, you want to do it with the one statement, your choice. I'll probably write the answer as two statements for now. make you guys describe this out loud here. I'll just post it up there so you can see. So there's what I got. All right. So remember 3, your degree is 3. Right? Number 3, the degree is 3. If you multiply this all together, do you actually need to like multiply all of these parts together and get like the entire polynomial? No. Okay. Just look at the highest degree terms for each kind of like factor there, I guess I'll say, right? And just multiply those together. So in this case, right, the x times the x times the x will give us x cubed, right? And that's, we don't need to worry about like foiling or anything like that. We're only worried about the highest degree term. So that'll be created by the x's multiplied together there. And it'll be a negative lead coefficient because it's negative x times a positive x times a positive x. So negative lead coefficient, odd degree, boom, we got our end behavior there. Here, this one's already put together for us, okay, and now we've just covered all of our bases. 1, 2, 3, 4, it's the 4 different, situations. Even positive lead coefficient, odd positive, odd negative, even negative as well. Okay, so it gives you all the situations there. Okay, so any questions on any of that? All right, so let's actually sketch the graphs of some polynomials then. I'll do one with you guys, and then I'll have you guys try one on your own, and that'll be that. Okay. All right. So sketching the graphs of polynomials, and the word sketching here is true. It's truly going to be a sketch, okay, for reasons that will become apparent in a few moments here, okay. So for right now, just, I guess, take my word for it. These are just sketches. We're not going to be able to get very accurate, precise with some of these graphs, unless we have calculus. And I'll explain why here in a second. Okay. So we're going to graph this polynomial here, okay? It's already factored for us, which is very kind. All right. Here are the kind of pieces that I will be looking for when it comes to sketching the graph of a polynomial like this, right? I would like you to find the zeros, okay, or in other words, the x-intercepts. Okay. I would like you to evaluate the behavior between the zeros. Okay, I'll probably refer to this as the middle behavior. Okay, it kind of makes sense, right? It's in the middle, not at the ends, so it's in the middle. Okay. I also, of course, want you to find or evaluate the end behavior. Okay, and then with all these components, graph. Okay, so given all these components, you should have enough to kind of come up with a decent sketch, a decent idea about what the shape of this graph is going to look like. Okay, but again, it will unfortunately just be a sketch. We really won't be able to find, make good sketches, I guess, or good graphs of these without calculus, but we'll at least have a pretty good idea. All right, so number 1, zeros, or the x-intercepts. Well, to do that, right, we'll set this thing equal to 0. Okay. And so with this setup here, Adrian, what are our zeros going to be?
0, -2, and 4.
You got it. X equals 0, x equals -2, x equals 4. Okay. So then for the behavior between the zeros, that is the middle behavior, we're going to put these zeros in order, and then we're going to pick numbers that kind of are between the zeros. Okay, so I'm going to put the -2, the 0, and the 4 here in order. Those are my zeros. Okay, we're just going to pick a number between -2 and 0. So what will be a good number to pick there? -1, sure. Okay, so we'll try x equals -1, and then what about between 0 and 4? What can we pick? 2. You can do 1 if you want to. You can do 3. I like to do the ones that are exactly in the middle. Okay, that's just like how I roll. But if you want to do like 1, you want to do 3, that's your choice. All right, I'm not going to like, fault you either way. So I want to figure out what's happening in my graph between -2 and 0. I know at -2, we're on the x-axis. At 0, we're on the x-axis. But what's happening here? Are we going up and then back down? Are we going down and then back up? Which one? So I'm going to plug this into the function g and find g of -1. Okay, plugging it back in, I get -1 times 1 times -5, which gives me 5. And so I now have the point -1, 5. Okay? So we can see that between -2 and 0, we're going to go up and then back down. Okay? And then let's see here. Now we'll try 2. So g of 2, okay, is going to be 2 times 4 times -2, so -16. And so I have the point to -16. And so between the 0 and 4, I'm going to go down and back up, right? Because I have to go down to -16 and then back up to the 0 there. Okay, and then let's also describe the end behavior here. Okay, so again, g of x, if we kind of multiply everything out, okay, what will be the degree of g of x? 3. And what's the lead coefficient going to be? Positive or negative? Positive. In fact, what will the lead coefficient be? What will it be exactly? It'll be 1, right? Because it's 1x times 1x times 1x. So we're going to have 1x cubed plus, and then some other junk. But we don't care about the other stuff. We just care about the fact that we're odd degree positive lead coefficient. So I'm going to write this single statement here. As x approaches plus or minus infinity, g of x will approach and then what? As x approaches positive infinity, g of x will approach what? Negative. Positive infinity in this case because we have a positive lead coefficient. Yeah, so it's going to be plus or minus infinity as well, just like that. Okay. So as x approaches positive infinity, g of x approaches positive infinity. As x approaches negative infinity, g of x will approach negative infinity there. Okay. But if you want to keep it in 2 statements, that's fine too. All right. Now we're going to use this little space over here to sketch that graph. So let's see here. I think get away with doing something like this, and then something like this. Okay. So I'm going to, let's see here, on the x-axis, since my zeros are the only things I really have to graph, I should be able to get away with counting by ones there. So, okay, so 1, 2, 3, 4. So 0 is at -2, 0, and 4. With the y-axis, though, it's a little bit trickier. I have to go up to 5, but I also have to go down to -16. So I'm probably going to count by 2s here. Okay, I'm probably going to count by 2s. So, and you only have to indicate one tick mark, and then I can just assume everything else will be counted by 2. So 4, 6. Okay, that's fine there. And then 2, 4, 6, 8, 10, 12, 14, 16. I'll go ahead and mark that for myself just so I can remember. All right, and now we'll plot those other points. So -1, 5, so 2, 4, and then halfway between there is the 5. And then 2, -16, so 1, 2, and then all the way down. And then we graph the end behaviors, right? As x approaches positive infinity, g of x approaches positive infinity. So as we go farther and farther to the right, we're going to go up and up and up, right? So I'm going to go to my farthest right point that I know, okay, is on the graph, right there, my 0. And I'm just going to kind of, draw like a little up arrow there if you like to. If you need that, put it down. If you can just graph the graph, feel free. Okay, I'm just doing this to kind of help out. As x approaches negative infinity, that means as we go further and further to the left, so here's my furthest left point, we're going to go down. And so from here, I know I need to go down, okay? And so now I will connect the dots. I need to go down from here, right? And then I'm going to go up, touch that, go down to back hit the 0. Now I have to go down to hit this point. I'm going to go back up and hit my last 0. And I know the last 0 I have to go up from. And so there's my graph, or the sketch of my graph, I should say. Okay. The nice thing is you can check this using your graphing calculator, right? So I'm going to type into my graphing calculator the original function here, x times x plus 2 times x minus 4. Okay? And there's my graph. I'm going to adjust my window to be similar to what I have right here. So in this case, my highest point was, let's see here, my x, let me do my left and right. So to the left, I did negative, well, I'll go like -3, I guess. And then 1, 2, 3, 4. So I'll say like up to x max of 5. Okay? My y min, I need to go down to at least -16. So I'll do like -20 there. And I have to go up to a height of at least, well, 5. So I'll go ahead and go up to 6 just for that case. Okay? So let's graph this and see here. Okay? And so there it is. All right? It's going to be important that you guys are able to adjust your windows and stuff like that to fit graphs and things, especially if you're planning on going to calculus. So, I'd recommend if you check, do check these and then, adjust your window to kind of make it fit better. Now, we can actually use our graphing calculators to find the highest point here and the lowest point right there. Okay, so if I do that, which command do I want to use? So let's say I want to find this point right here. Okay, let's say I actually want to find what that coordinate is on my graph. What command should I use? Maximum, right. Okay, so we'll go to the left of the maximum, hit enter. We'll go to the right of the maximum, hit enter. The guess part, I think, is for us to go like close to what the actual maximum is and then hit enter again. And you'll see here, okay, that the maximum is not -1,5. Our graph shows it happening at -1,5. It is not exactly at -1,5. It's a little off. Okay. Likewise, if I try to find this point right here, which is a minimum, I'll go down, go to the left, go to the right, go down towards the guess there, and you can see as well, it's not quite the lowest point, right? The x-coordinate's 2.4, the y-coordinate's like -16.9, almost -17. So again, that's why I'm saying we're doing sketches here. These points, they get us pretty close, but they're not exact. And you need calculus to get exact, okay, where those are. Get exactly where those are. Now, we called this thing a maximum. We called this thing the minimum. Is this maximum the highest point on the graph? No, why not?
Because the end behavior, it goes up into infinity.
Exactly. So we call this thing a maximum. But it's a relative maximum. Relative to the points around it, it is the highest point. Okay? Is it the absolute maximum? The answer is no, right? It is not the highest point. Okay? This point right here, what would we call this? Not just a minimum, we would call it a what kind of minimum? Relative minimum, not absolute minimum, because it's not the lowest point. This keeps going. Okay? So that's the idea there about relative extrema. On a quadratic, you do have a relative or an absolute max or absolute minimum because it is the highest or lowest point.
And if it's an even degree polynomial in a higher degree, since the end behaviors go both one way,
exactly.
Then there is
an absolute max or an absolute min. Yep, exactly right. Exactly right. Okay, so for an even degree polynomials, you will be able to identify roughly, that it has an absolute one. But for odds, you're not going to have them unless you limit their domains. Okay, so here's one for you guys to try. -2x squared times x minus 2 times x minus 6. Okay, so give that one a try. Again, zeros, the middle behavior, what happens between the zeros, and the end behavior. Okay, and then graph it, of course. And I will do the same. Feel free to use your graphing calculator after you've graphed it to check your work. Okay, but try to avoid using it to spoil yourself. also make sure you choose an appropriate scale for your graph as well. The x-axis and y-axis can be different, of course, too. Question, or feel if you're stuck, you may just check something. Be happy to help out. Yes. Oh, I see. What's the square root of 0? 0. 0 is square root of 0. No, yeah, square root of 0 is okay. Square root of negative, not okay. Square root of 0, okay. So then, yeah, and you found. So then, one more point between the other 0 and the old 0 that you have here. Oh, geez, man. What's up? Well, what do you think you should do? It's a really big number, right? It's not just the y coordinate, so the x coordinate's no problem. I mean, that's not a big deal. So how should you adjust your y-axis? What do you think you should maybe do? If you want to, okay? I would also suggest maybe like, I see how you've drawn your axes there. Okay, you have them drawn kind of like this. But you don't have to draw them like that. You could draw them like this, for example, if you wanted to, right? So you can give yourself some more space for where you need it and stuff like that. But yes, I would recommend that you don't count by ones on your y-axis. But otherwise, you have a chance. It is. Remember, it's the end behavior. Where does 4, 128 occur? Right, between and up here. And so you're going to go up to this point, wherever it is, back down, and then from this 0, as you go further to the right, you're going to keep going down, down, down. So those hands go up and then down. Does it make sense now? Okay. Now you missed one of your zeros there too. Oh wait, no, you do have a 0 there. You just plotted it. You should come up, and you did. You have 1, -10. So don't forget to plot 1, -10 as well. You have those both those points. Okay. And then remember, it goes to negative infinity on both sides. Question? Yep. So what's even in this case? So x squared.
Yeah.
X squared. So the 0 that you get from x squared, it bounces.
Okay.
Right? This one is degree 1. That's degree 1. So they go through those.
Okay. Oh, that's what it was.
0. Yeah, exactly. It's more about whether you have a double 0 or.
Because I remember something about that from last year, but it didn't make sense when I got to it. I was just thinking about it wrong.
Yeah, that's all. You're on the right track. On the right track. That's fine. Now, did you do that to them, or did they come that way? See, that frustrates me though, because I never know. Am I supposed to pull from the bottom up? Am I supposed to pull from the top down? I never remember. I know, but what my point is, do you understand what my point is though?
Yeah.
When they're sitting there on my desk,
No.
which one am I supposed to pull? From the bottom to the top, from the top to the bottom?
No, I use this at my internship, but I'm not allowed to do this at my internship. I fidget
You're not allowed to
spinning.
have fun at your internship.
No, as my person as an intern, I do 3rd grade. The kids have accordion sticky notes. So
Oh, yes, you want to model good behavior.
Are tools that
Yes, yes, you want to model good behavior for your little 3rd graders.
They're a little devils.
Yeah.
They're little devils. They love to talk.
I'd love to talk back to them, yes.
I could be the person I interview.
Yeah. It's tough. It's tough. Does anyone still need more time? We're good? We're looking pretty good here. This part plays kind of like. Oh, okay. All right. Well, here's an idea, okay, of what you would see there. Okay. So, how many absolute minimums do we have? None. None. Because the end behavior goes down forever, right? The end behavior goes down forever. So there is no absolutely lowest point. It keeps going right here. Okay? How many absolute maximums do we have? 1. Where does that one occur? Yeah, approximately, right? Because it's not exact, but like it's between at least these 2 zeros right here, the 2 and the 4. Somewhere in there, we're gonna have an absolute maximum. Okay. How many relative minimums do we have? 1, and it occurs between the zeros of the 0 and the 2 there. Okay. How many relative maximums do we have? We have 2. Okay. The relative maximum. Where the absolute maximum is, we also have a relative maximum right down here. Because, again, in that neighborhood of points, so again, we have a relative maximum here. We also have a relative maximum right here in this little neighborhood of points. That is a maximum, okay, in that area, right? And then we have that relative minimum right there. Okay. Again, I'm, just helping you practice this some. If you're planning on going to calculus, it'll be helpful to be able to recognize those things too. Get that vocabulary down, because that's a tricky concept. They both have the word maximum, minimum, but one absolute and then relative, and they're kind of different. So sometimes they're the same, but sometimes they're different too. Okay, so your assignment is already posted to Google Classroom, so if you want to go ahead and get started on that, all right, you can do that. I will also post up the bookwork assignment that I meant to post yesterday for quadratics. I would recommend you look at least the word problems. I think it's like the last 2, I want to say.
Are there word problems on the test?
There could be.
Yes.
I would hate for you not to be prepared for something, right?
Word problems.